This is a ZenoLink data view analysis for baseball pitch. We'll begin the performance profile. We're going to look at just a couple key numbers. Arm speed at release, which is the speed at which the wrist is moving in miles per hour, so well above average, which would indicate good potential ball velocity. Internal rotation speed also above average, which also indicates the potential for really good ball velocity. Lower body speed output a little bit lower than what we would expect. Shoulder segment pretty much exactly where we would expect it. But all in all, the numbers look really good. So it would indicate that we probably have some pretty good basic biomechanics going on. When we look at the kinetic link, that's exactly what we see. The first thing to understand is what we're going to get here is as the front foot comes into contact with the ground here, the foot pushes against the ground pushes back. That force is translated through the ankle, the knee, to the hip, which creates rotational speed at the pelvis. That engages the core musculature, which then accelerates the upper torso. So you get a sequence of events there, which then accelerates the upper torso. So we can move this along here. Upper torso accelerates. As the upper torso accelerates, the arm goes into loading. So what happens is this accelerates, this gets into about a 90-degree position and goes into external rotation, which loads the internal rotation. The 90-degree angle is important because that creates a lever arm, a large moment that forces a large load impulse on the internal rotators, which are going to then produce the bulk of the speed. So that as the athlete moves forward, the upper torso, so there's your load process, the upper torso will now start to decelerate. The arm will now start to internally rotate the shoulder at the same time extend at the elbow, now reducing the moment arm down to zero and using that great force that's created at the shoulder to internally rotate. You can see the elbow extends to almost straight, which minimizes the moment arm. So the resistance, the moment of inertia resistance against internal rotation decreases dramatically as the shoulder internally rotates and releases the ball at some velocity. So we want the high arm speed to come from high internal rotation speed. Okay, so we're looking at foot contact to ball release. And what we have is really a very nice kinetic link. Lower body accelerates, transfer speed to the upper body, which then loads the arm in this zone, facilitating elbow extension at the elbow, rapid elbow extension, perfectly timed, with internal rotation reaching its peak pretty much at ball release. So we have all the nice coordination that we would expect for a high velocity pitch, efficient mechanics for a high velocity pitch. But we do have some breakdown issues or some breakdown areas that will improve our output, our speed output, as well as our efficiency. The first is that lower body mechanics occur a little early rather than after foot contact with a slightly better connection. And we can take a look here at this graph. It'll show us a little bit better. Here we see here's our peak hip and here's our peak shoulder. This occurs a little early. We'd like to see it occur just after foot contact, and we'd like to see a more connected relationship between that and the upper body. So although it's there and it's effective, it can certainly be more effective, which means it's going to be a more efficient, more powerful, more speed-oriented kinetic link. The other thing is elbow extension is a little slow. We get this kind of big arc. We'd like to see it a little bit sharper here, boom, boom, which would improve the efficiency. If it's a little bit sharper, it would improve the efficiency of internal rotation, which will only improve ball speed and arm speed, but also make that process just a little bit more efficient. So the next thing we can look at then is stride mechanics. If you look at the athlete, stride mechanics look pretty good. About 150% of the leg length, which is what we would expect. Stride direction is a little bit closed, which we would expect. The foot is a little bit open, and at foot contact, we can back up here. So the foot itself is open. Even though the stride is closed, we're coming in this direction, the foot is actually open a little bit, which decreases the ability to create hip speed, which is what we saw. And so you're going to see that. You're also going to see, so you'll see here, the foot comes into contact with a slightly open position, which makes it hard because the foot is pushing this direction. We want the force pushing this direction, so they're a little offline. So this makes translating the force, creating and translating the force off the ground a little bit harder. As far as lead leg stabilization goes, though, I mean, doing a lot of stuff right. Comes in at about what we'd expect, 45 to 50, maybe a little bit more knee bend than what we expect, but stabilizes like crazy, which is what we want. So lower body mechanics, except for the foot being a little open, look really good. As far as our trunk flexion extension goes, though, we have a little bit. You can see here as he moves forward, he's in really good position here as he starts to load. I like this. He's in good position for the loading and reacceleration of the internal rotation there at the shoulder. And we'd like to see him then bend forward just a little bit, but he bends forward a little too much. So here now, he really bends forward, snaps you can see right through the thoracic in particular, that forward flexion and a lot of left bend. So a lot of trunk movement, which pushes the arm way out ahead of the body. I mean, we want to see some trunk movement, but he's just a little bit too much. So we want a little bit more stability, a little less movement on the trunk. Again, these are subtleties, but they're going to help. As far as loading, obviously, the better this acceleration connection is going to be, the more we're going to see the load after foot contact, which is going to be more effective. Arm load looks pretty good, but we'd like to see maybe a little bit more like this. So it's loading in here rather than a little early and then stays there and then comes out a little late. So arm dynamic could be a little bit better, but still looks really good, you know, overall. And then arm speed looks good. I think that the only thing that you can see is maybe a few more miles per hour downward and outside across, just because of the orientation of the trunk being so much more forward and left bend. So we can clean that up. It just means, I mean, there's a few miles per hour that are wasted in terms of developing ball speed. So you can have great arm speed, and ball speed can be so-so for a lot of reasons, but one of them is just the delivery, the direction of delivery, and that's what we're seeing here. So we've got a lot of really good things going on, but we can improve lower body speed output, improve core connection and core stability, and then connect that to slightly better, more effective arm dynamic. Although all of them are already pretty good, we can improve those, improving efficiency as well as the potential to create ball speed.